Different operating systems have different approaches for both user interfaces and system calls, depending on the level of complexity the operating system had. For example, for MS-DOS, which was a very simple system that supports only one user and only one process at a time. Things were pretty easy, needs were minimal. We don't have graphical user interface, we have only command line interpreter, or CMD as they call it, and there wasn't much, the need was minimal for system calls actually, because there were no process creation, there were almost no communication, because in the main memory you'll find the operating system, the command line interpreter, and one user process. That process will continue executing until it finishes executing and it exits. So there were no need for system calls to manage memory or to manage processes or for communication. It was minimal. The need for communication was next to nothing. Protection was actually implemented by hardware. So need for sophisticated, complicated, complex system calls was not there. Unix, that has actually introduced the concept of multi-programming, where multiple processes coexist in the memory, has complicated the level of system calls needed to manage user process and operating system. There exists need for memory management, for process management, for communication, for resource allocation, for memory allocation. So things got complicated. Definitely, as the operating system has become more complicated, more system calls were needed, and relations between different number of sets of system calls needed to perform a certain task has grown impressively, I may say. Now we have actually had a look into the first two layers when we are considering operating system services, which were the user interface and the system calls. Now the third layer is the system programs that actually do the job, that actually carries on what a system call brings into the operating system. An open file system call will trigger several system programs in order to fulfill to get the end result, to open that file. So we have user programs for file manipulation that opens, creates, deletes, renames, relocates, searches files. For status information, to get dates, to get free space, to get time. For language support, and these are linkers, loaders, and different types of libraries. Okay. For communication, to send, to receive, to create buffers, to create mailboxes. For background services, these are services by the operating system like protection, security, and networking, and application programs that can be part of the operating system or of the user space. Most of users' view of the operating system would be the file system, where they deal with files, whether these files were data files or program files. They open, close, execute files. So the file system manipulation is a great deal of what the user actually think of an operating system. What if we need for system programs? The system programs are there to provide a convenient environment for program development and execution, for file management, for status information, for file modification, for programming languages support, linkers, loaders, interpreters, compilers, for programming loading and execution, and for communication between various processes that is running on the computer system, and to support background services, as we have said, and to support application programs as well. Okay, now we understand, not very deeply, what services the operating system actually provides. So, how will the operating system do its job? It's now our turn to understand how operating system is designed to enable us to be able to participate in designing or at least improving existing operating systems. Operating system is a software, just like any other software, has to fulfill both user goals that express the user needs and system goals that expresses the developers and the administrators' needs. The users are actually addressing the operating system from the front end, and those are the guys, the developers, and the administrators are dealing with the back end of the operating system. So, what does a user want? A user wants a convenient, easy to learn, reliable, safe, fast software that enables them to execute their programs. Whereas system goals are different because this is the view of the developer and the administrator. They want an error-free, a reliable, a flexible, a maintainable, a sustainable, and efficient program. Sometimes they would be, not sometimes, almost all the time, there will be clashes between what the users want and what the user goal and the system goals. They might contradict, and there will be conflicts. And like any other design process, it's a trade-off where you decide which quality is more important and is more needed than the other. So you will focus on implementing in the design in this, but not that. One important concept that any designer has to be very well aware of is to separate mechanisms from policies. It's separating what is needed to be done from how it's done. Because what is needed to be done is a high-level design concept that should never ever be tied to how this will be implemented. That will restrict your design, and most probably will cause you to have poor solutions for your problems. A policy will will tell you what is not, what is needed to be done, while the mechanism is a way of doing this. It will tell you how is this be done, and different policies can be, a single policy can be implemented using different mechanisms. So never tie them together. After designing the operating system, there will be implementation. And this implementation, that's to say, we will code it. Operating systems are usually coded in high-level languages, mostly C, C++, and sometimes Java. And Perl and Python, usually implementing operating system, implementing any software, if it's well designed, is not a big deal. It's absolutely no-brainer. But after implementing the operating system, the important thing is to actually test this operating system and see if it fulfills the requirements, functional and non-functional. Does it provide the services it should provide? Does it actually provide the non-functional requirements like reliable, easy to learn, and كل الكلام اللي قلناه قبل شوية.